Hello, students. Today we are going to be focusing on the scientific method. Now, this is something we have covered before, but I really need to make sure we understand this because scientific investigation is going to be about 40% of the GED test. Now, all the questions aren't going to be super difficult, but they are going to involve different parts of a scientific investigation. So, for us to fully understand a scientific investigation and how to do it, we first need to understand the scientific method. All right. So, the scientific method was something that was created many centuries ago. I believe during the Renaissance is really when it took off. But even before that, scientists had been taking a step by step approach when trying to discover new things about the world and the universe around us. All right. So, one of these first things that they always did, and that was incorporated into the scientific method, is observations, is to observe. So, what we mean by observe, we mean look at the phenomena that is happening around you. So, there's a famous story about Sir Isaac Newton and apple falling off a tree and hitting him on his head. I don't know if it's true, but we keep retelling it even though. Now, there's many other phenomenon that we can recognize. So when that apple hit him on his head, he started thinking about, well, what made this apple fall? But it could also be something as simple as just the waves moving when we look out at the ocean. It could be the sound we hear when a fire starts to flicker. It could be a sonic boom. All right. Why is the thing that's causing the sonic boom so far past us before we actually hear that loud boom sound? So there's many different phenomena that we can observe in the universe around us, and many that have still yet to be answered. But the first thing is to make an observation about the universe around you. Now, after we make this observation, it's typically a very good idea to go ahead and try to do some research about this observation. Now, I know we had some trouble doing some research and probably going to do a lesson on showing you guys how to research, because this is going to be something that you're definitely going to need when you go into post-secondary and even when you go further into your actual careers, your actual jobs. We need to know how to be able to do effective research. Now, when we're researching here, after we've made this scientific observation, we're researching for work that has already been done concerning this particular phenomenon that we have observed. So say, for instance, why the waves, why we even have waves, why the water is just, flowing and bouncing back and forth. There's much research on that. And thankfully, you guys are watching this on some kind of smart device or computer. There's many answers and a lot of information we can find through our computers from a simple search using Google or Bing or Yahoo, or if you want to use a artificial intelligence, so one of the smart assistants, so you can use Windows Cortana, you can use Google, you can use Siri. I forgot what the one on the Samsung is called, but you can use any of these to try to find additional information. Okay. And I'm going to show you guys later on how we do effective research. But after we observe, we do want to do some research about this phenomenon to try to give us some ideas of what's already been figured out, what's already been answered, because we may not need to do a whole scientific investigation if we already have an answer, if there's already a scientific theory there to prove our phenomenon, or we might just want to repeat someone's said investigation to prove and make sure that it's true. All right, that's all what the scientific method is about, to be able to verify things becoming a scientific theory. All right. So if somebody does this experiment, they took these particular steps, which we're going through now in our scientific method, and we want to be able to verify what they did. So this is another reason for the scientific method. Now, after we've observed some type of scientific phenomenon, we've done some effective research on that phenomenon, we then want to pose a question. All right. What is it about this phenomenon that makes you wonder? What is it that we don't understand that we want to understand? So going back to that example with Sir Isaac Newton, with the apple falling off of the tree, with it hitting him in his head, he started asking, well, what made this apple fall? Why did this apple not just come unattached from the branch and just float in the air? Or why did it even come off the branch to begin with without anyone, pulling it, without anyone putting any force on it to make it fall? All right, that is the question that he asked. And we can ask many other questions when we look at different phenomena that happen around us. All right, but we want to be clear when we ask these questions, we want to make sure it is a testable question. This is the issue we fall into sometimes when we're trying to create a scientific investigation. Our questions aren't really testable. I don't want to ask things that are abstract. All right. So I don't want to ask something about like, is God crying when it rains? All right. So that's something, and no matter what your beliefs are, this is not something we can really test. This is not something that's tangible. All right. Like it could be true. It possibly could be true that when it rains, is God crying. But that's not something that we can test for. We can't go up there wherever God is and see, oh, are tears coming down or are tears not coming down? That's not something we can test for. When we ask the question, it needs to be something testable. It needs to be something that is tangible, that we can come up with concrete proof. Okay? So if you're asking a question, and when you're asking a question at the same time, you can't come up with any kind of way to test your question, then you probably want to repose it a little bit. All right. Now, after we ask our question, then we are going to answer our question, right? So you ask the question and you answer it, but this answer isn't going to be, it's not necessarily true, but it's going to be a hypothesis. All right. It's going to be a testable answer to the question that we posed. Now, the whole point of the scientific investigation is to determine if our hypothesis is going to be true or if our hypothesis is going to be false. All right. So whether we were right in our assumption or if we were wrong. Now, when we are hypothesizing, when we're making this hypothesis, we want to include two very important things. And I'll be going over this in a later lesson in deeper detail. But your hypothesis should always include the dependent variable of your experiment and the independent variable of your experiment. So the dependent variable is basically going to tell us if our hypothesis is true or false. The independent variable is going to be the one thing in the experiment that we are affecting, that we're changing the value of, or that we're making different. Everything else in the experiment, we are going to be making sure it's the same throughout every single test. We're controlling for those variables. And again, I don't want to go super deep into that because, we can spend 30 minutes just on that. But when we create our hypothesis, our testable answer, okay, again, it needs to be something that we can test. It needs to be tangible. So think about that when you're writing your hypothesis. But it must include your dependent variable and your independent variable as well. So when you're creating the test, you shouldn't wonder, oh, what is my dependent and what's my independent? Well, it should be in your hypothesis. Okay. Now, after we create our hypothesis, after we have this testable answer, well, it's time to test the answers. Time to test our hypothesis to see if it's true or if it's false. So this is the major part of the scientific investigation. This is the experiment. So the creation of the experiment, the execution of the experiments for doing it, and collecting the data while we do our experiment. All right. Excuse me. So when we're creating this experiment, we want to make sure it's not flawed. So I mentioned before, I was talking about the hypothesis. We want to make sure we are controlling for different variables. All right. So say, for example, let's go back to the apples, right? So we're testing out these apples back with Sir Isaac Newton, trying to figure out gravity. So if I'm trying to figure out what's happening, and maybe my hypothesis was the apple fell off the tree because it was too heavy. Just the weight of the apple pulled it down. All right, my hypothesis was the weight of the apple pulled it off the tree. So if that's what I wanted to test for, then I would need to be looking at an apple tree, and probably just one apple tree in particular. And I would look at different apples of different sizes on the tree, and I would just sit there and watch and just, see which ones were going to drop and see if it was true or not, if the weight of the apple had an effect on if it was going to drop or if it wasn't going to drop. And since it's all on the same tree and it's all on the same branch, I'm controlling for as much as I possibly can in that particular scenario. Now, there's also other experiments you guys will get. One you see a lot of times is things in the garden, right? So maybe I'm trying to figure out which manure is going to work best to grow my flowers. So let's say I'm trying to grow some roses. All right, I don't know a whole bunch of different flowers, so I'm just going to use roses. So for the roses, they need to be put in the same type of pots. They need to get the same amount of light. They need to get the same amount of water. The only thing that should be different is the type of manure. If I'm trying to figure out which manure works best, that's the only thing that should be different. So when we are creating our experiments, you want to make sure you control for that. Now, again, we'll go deeper into that later on when we get into the different variables of our experiments. Now, while you're doing the experiment, you want to make sure you're collecting the data. So as you do the experiment, you collect the data, because we're going to have to use that data to determine and justify the very next thing, which is our analysis and our conclusion. So after you've done the experiment and collected the data, we need to analyze the data and draw a conclusion. So you're analyzing the data to help you to determine if your hypothesis was true or if your hypothesis was false. And it's okay if your hypothesis was false. We don't want to get into this confirmation bias type of thing and just kind of mess up our experiment or invalidate our experiment to try to make ourselves be true, to make our hypothesis true. If our hypothesis is false, it's okay. That means whatever we thought was the cause for this particular phenomenon, whatever our question was, whatever we thought the answer to our scientific question was, wasn't true. That means we can do additional research to determine what is the case. Okay. Now, Scientific method. So you see we have this listed out here in this particular order: observe, research, question, hypothesize, experiment and collect data, then analyze data and draw conclusions. Now, this order isn't always going to go like that. So say, for instance, what we just mentioned. So we said we finished the experiment, right? We analyzed the data, we drew the conclusion, but our hypothesis was false. Well, I could change this, and if I've already done an experiment, I may not need to do more observation because I already know the phenomenon that I want. So what might happen is that after we've analyzed this data and we drew a conclusion and we found out our hypothesis was false, well, we're just going to jump right back into it. We're going to do some research. We're going to keep the same question, but we're going to come up with a new hypothesis. Then we will experiment and collect our data, and then we'll go back and end again with analyzing our data and drawing a conclusion. But this can look a lot of different ways. These can move around. So sometimes after you do an observation, you may not just necessarily jump straight to research. You might do an observation and you might have your question second, and then you might do research. So you might observe something, some scientific phenomenon, ask a question, do research about it, then create your hypothesis. All right, so think of these more as individual modules in our scientific method. Don't think of it as, oh, it's always going to be in this particular order. Every time I do the scientific method, it's always going to be in this order. That's not always the case, depending on what field of science you're in, depending on really what the phenomenon or exactly the situation that you're in within your scientific investigation. All of this may not be necessary. All right, we may not need to do an observation. We may not need to do research sometimes. Sometimes, we might just start with the research. All right, so you might have just been given, some kind of assignment in school or assignment at work where you don't necessarily have this phenomenon, but you have this research that you need to do. They're telling you the phenomenon that you need to research. You're not observing it. They're telling you this is what you need to research. And then you're asking a question about it. Or they might just forget about the research. They might just tell you the question and you need to come up with a hypothesis, create your experiment, and collect your data. Okay? So again, these are different modules that can be moved all around. It's not always going to be this nice, neat order right here. And sometimes these will loop back around with one another too. So we might do an observation, we might do research, we might ask a question, and then after we ask a question, we might have to loop back around and do more research, and then come back down to our hypothesis. All right. So I'm going to end it here. I'm working on trying to keep these a little bit shorter. So I'm going to end it here. And as always, stay safe and be blessed.